Okay, so for our number 4, it's a little bit more complex than the last one where we had to rationalize, because now we're going to talk about what happens when I have a cube root. So I have a squared b all over the cube root of 3c. So if you notice, there's nothing that you can actually divide, so you always want to check that first. You know, can I reduce a fraction? Can I join two variables together? I cannot in this case. Now I'm used to rationalizing, and when I'm rationalizing, I'm going to go over here. Like for our last problem that we had, I multiplied by the square root of 2 over the square root of 2. Now with that, note, I had a square root. A square root is a root of 2. Therefore, I needed to multiply one square root times itself, and so because it's a root of 2, I needed it twice. Okay, so a root of 2, I needed this to happen twice. Over here, I have a root of 3. So what that means is I've got the cube root of 3c over the cube root of 3c, but if you notice, it's a root of 3, but right now I only have it twice. So that means I'm going to have to do it again. So with a root of 3, I should see in the denominator cube root of 3c. I need to see it 3 times because it's a cube root. Okay, that's very, very important, and I'm going to show you why here in a moment. So now at this point, I have 3 of these because it's a cube root, so I'm in good shape. So I'm going to just multiply all the numerators across and multiply all of the denominators across. So for my numerators, my whole numbers, I've got 3 times 3, which is 9. Then I've got a squared b, and then I have c times c, which is c squared, all over. Now my denominator, 3 times 3 times 3 is 27. C times c times c is c to the third power. And so what I want to do is, and at this point everybody's like, oh, but I can reduce that. Nope, nope, nope. Please don't do that. Don't do that. What I want you to do first actually is to simplify the denominator. Okay? So I'm going to simplify that 27, and I get 9 and 3, and here I've got 3 and 3. So I've got a group of 3's. I've got a group of 3 3's. So I'm going to take out a 3. Then I'm going to do my exponent divided by my root. 3 goes into 3 one time with a remainder of 0. So I'm able to take out a c to the first power, and nothing's left in. That looks familiar, doesn't it? So truly what I did here when I have a square root times itself, and it's just whatever's inside, when I have a cube root and I do it properly by having 3 of them, what's going to happen in my denominator is it's going to be whatever's inside, but I have to do it 3 times, okay? And at this point, now what I need to do is actually simplify my numerator if I can. I know with the 9, it can only break up into 3 and 3, so therefore that 9's going to stay. 2, if I did 2 divided by 3, well, it's going to be a 0 with a remainder of 2, so that a squared's going to stay in. The b to the first, going to stay in, and that c squared is also going to stay in. So there was actually nothing in the numerator that I could take out. Sometimes there can be, so you always want to be aware of it, but sometimes there can't be. So it really just kind of depends there. Okay, so that is going to be my final answer with that. So please note this was a cube root, so I had to make sure I had 3 of them. And again, whatever I'm multiplying by, it has to be the same numerator and denominator. So now let's look at number 5. Number 5, I have the 4th root of 5 over the 4th root of 3. So if for a square root, if I should see it twice in the denominator, and a cube root, I should see it 3 times, guess what the 4th root's going to be? I'm going to need to see that 4 times. So I'm going to need to write it. If you notice so far, I only have 3 of them and I need 4, so I need to add on 1 more. Okay, it's kind of weird, I know, but it's mainly to be able to kind of like use your shortcut per se, without, I guess, making it too overcomplicated. So what I'm going to do is now I have 4 of my 4th roots, so I can just multiply my numerators. So 5 times 3 times 3 times 3 gives you 135 all over. And so now, because I have 4 cube roots of 3, I'm just going to get 3. I'm going to get whatever's inside. Now, to actually demonstrate that, if I had the 4th root of 3 times 3 times 3 times 3, I get 81. And if I break up the 81, I can do 9 and 9. Then that I get 3 and 3 and 3 and 3. And because it's a 4th root, I have to have 4 of the same numbers. So I just take out a 3. So again, I'm just kind of showing you that shortcut with it, but showing you the reasoning behind why I get a 3 there. Okay? Now, ladies, I know right off the bat that I'm finished, because if I'm trying to find the 4th root of 135, think about what made up the 4th root of 135. It was a 5 and 3 3s. Those are all prime numbers. There's nothing I can do to break it up, so therefore I'm finished. If you really want to go about it and, say, okay, 5 times 27, and the 27 you can do 9 and 3, and the 9 you can do 3 and 3, and see all of that, that's fine. But sometimes you want to work smarter, not harder. And so I knew what made up the 135, so therefore I knew that there would be no groups of 4 that I could take out. So my final answer for number 5 is the 4th root of 135 all over 3. And I've got one more problem for you. And so I've got the square root of 12x to the 9th y to the 4th z all over the square root of 2x squared y to the 5th z to the 2nd power. So with a division problem, you want to divide first as much as you most humanly possibly can. Okay? So what I can see is the 12 and the 2. 12 divided by 2 is 6. So I get the 6 there. Then I'm going to look at my x's. So I have x to the 9th over x to the 2nd. 9 is bigger, so my x is going to stay in the numerator. And 9 minus 2 is 7. And then I have my y's. So the y is bigger in the denominator. So then I do 5 minus 4, which is 1. So it's y to the 1st. You don't really have to write the 1. And then I have my z's. Z is bigger in the denominator, and 2 minus 1 is 1. So again, I don't have to write that to the 1st power. I can just write z. So if you notice now, I am going to have to rationalize this denominator. So I've got the square root of 6x to the 7th all over the square root of yz. And so because it's a square root, I should see it twice. So I've got square root of yz over square root of yz. And if you notice, it's twice, so I'm good because it's a square root, which is a root of 2. So that's why I should see it twice. So now I'm going to multiply my numerators together. So I just have the 6. There's no other number to join with the 6. The x, there's nothing to join with, so that's x to the 7th. And then I have yz. Okay, and then in my denominator, it's because I had a square root and I did everything correctly. The square root of yz times the square root of yz is just going to be yz. Then I have one final step, and I need to see if I can simplify within that numerator. Okay, now I know 6 gets broken down into 3 and 2. So there's nothing I can take out there. However, I'm looking at this x to the 7th, and I know right off the bat that I'm going to be able to do something because my exponent is bigger than my root. So I'm going to have to do 7 divided by 2. 2 goes into 7 3 times, and I get a remainder of 1. So therefore, I'm going to take out an x to the 3rd, and I'm going to have a square root of x. So my final answer in my numerator, I'm going to have an x to the 3rd, and then I'm going to have the square root of 6x and then yz, because the yz, they're both raised to the first power, so the exponent's smaller than the root. And then in my denominator, I'm just going to have the yz. I'm always going to want to check of what's outside of the square roots, so to make sure that I can't simplify anything there. The x to the third and that yz, there's nothing you can simplify because those variables are not the same, so the bases aren't the same. So this then truly is my final answer. So with dividing, you're going to divide first as much as you most possibly can, and then you're going to simplify. And in the simplification process, you might have to rationalize denominators. So remember, square root, you should see it twice. A fourth root, you should see it 4 times. And then a third root, you should see it 3 times. So that's very, very important for this.